Alright, so roll joints are kind of finicky, but if you want to do it the quick and dirty way, like you're doing it, you're going to need to make sure there's a few things. First of all, like your main joint has to be running down the center of the arm. So the start point has to be where like the elbow is, which is what you have, end point where the wrist, obviously. But the orientation of the joint itself is very important. So you can see right here, the orientation of this joint is going right down and pointing straight at the child here. One thing I noticed in your image was that the orientation looked like it was a little bit off. So instead of it pointing straight down, it was like pointing out back a little bit. So you just want to make sure about that. If your orientation isn't right, you'll have to go up to your skeleton and then orient the joint. There's some like different options too, so you just play around with those till you get what you want. I usually use it so that way that the X orient is the main axis, and then the Z axis is either forwards or backwards depending on how its setup is. In this case, it's forwards, and then the Y is up because it just makes sense to have the Y up. The next joint though, the roll joint, you'll have to make sure that that also follows the same exact orientation of this joint here. So whatever this orientation is, the roll joint should be the same orientation, and also the wrist orientation should also follow the same. So if you notice, if I were to select all three of these and turn on, if I go to display and transform and then local rotation axes, you'll notice that all of these are, you can see they're all facing the same orientation. This is important because when you rotate one, you want the middle one to also follow along and divide basically between these two. The last thing you'll want to make sure you do before setting up the actual roll expression, or in this case I'm going to do parenting, or not parenting, an orient constraint. You want to make sure that your rotation order is set up correctly for the wrist. So you can see right now my rotation order is XYZ, which doesn't seem all that bad, but when you rotate this, you'll notice this axis is the one that we're going to divide by. So it's going to be like basically all the math is going to come from this one here. But you'll notice if I were to rotate it around the Y, that the X actually moves too. So basically, this right here should be perpendicular with the bone. So like when I move this, the red shouldn't move. So the one way to fix that is you go up to your rotation orders, and you're gonna go to a different rotation axis. That way, whatever rotation you do, like first, the X always gets solved the first one. And so the way to know that, basically you just look at it will be the last in the listing. So like if it's X, Y, Z, Z is the first one to get evaluated. In this case, it'd be YZX or ZYX. Either of those will work, but because X is the last one, that means that it's going to be the first one to be evaluated, which means that your math will be correct. So after you get that set up, it's basically, it just has to do with the gimbal lock. But that's a different subject. If you want to learn more about gimbal lock, I recommend looking into it. But let's get back over to this real quick. Okay, there you go. So there's two ways of making this roll joint work correctly. One is that you could select the, so I should say one last thing. Let me backtrack. This, you'll notice, is actually not part of the hierarchy. So it's not elbow, then roll joint, then the wrist, but it's actually elbow, wrist, and then also elbow and joint. You can see that this is like a different, whoops, I parented that wrong. This should be parented under here. So it'll be like basically the elbow goes right here, and then this joint and this joint are both parented to the elbow, so they're both child rhythmic. Then what you'll do is you'll select. You can do it two ways. You can either make an expression. Expressions are pretty simple. You can either basically what you do is you just select that. Go to Window, Animation, Expression Editor, and what you'll do is you'll take this roll joint name and you'll just go roll joint dot rotate X, because it's on my X axis here, the red one. You're going to say that equals, and then it's going to be my wrist, left wrist dot rotate X divided by 2, because then it will be half the divisions of this one. And you hit create, and then when you rotate this, you'll notice that whatever this is going to be halfway. And that will give you the kind of twisting that you're looking for that way. But you'll notice that, like, okay, yeah, it works the same way. So you can see, like, they're when you rotate that around, it should. Here, let me change my rotation real quick. So it does that. So that's one way of doing it, is writing an expression, which could be pretty fast to evaluate. The other way to do it, let me undo that real quick. Actually, I'll just delete it. The other way to do it is to do an orient constraint, which I mentioned earlier. Is you select basically the start and the end point, and then the roll joint, and go to constraint and orient, and then you're going to actually just, where it says constraint axes, you're going to turn them basically all off except for X, and hit add, and then that will basically do the same thing, where it's not evaluating for Y and Z, it's only doing for this X axis. So wherever you rotate it, it will evaluate halfway between there. So those are two ways that you could have that rotate, but you'll notice that, like, when I twist it up here, this axis is rotating along that center point. So that's why it's important to make sure that everything's oriented correctly and centered correctly. So if I were to do like a quick test bind for this real quick, select those, let's see, come over to skeleton, bind skin, smooth bind, bind, okay. Without the weight paints correctly added, it's going to give you garbage basically. So I'm going to add some quick weight paints just for, let's find this one here though. No. It is the left arm roll. And I'm going to make sure this is on interactive and replace. Whatever I paint here will override everything. Go to the arm, delete these ones up here because we don't want them. We don't want the arm to influence up here. It should only be influencing down here. So I'll just paint that out real quick. And then it'll be the wrist. The wrist will be a little bit more like right here. Just kind of smoothing those out. Okay, and now you can see, if I were to turn on the topology, it twists along that axis. So that's one way of doing roll joints. There's other ways too that are like more and less complex. You can see that this one has limitations, so if you go past like a certain point, it could break. You can see there's popping. So the expression method or the orientation constraint method is not the best result as far as that popping and stuff, but as long as you're not like, planning on doing some weird wacky like posing and stuff, you'll be pretty good. Like that's basically the breaking point of the rig. People's wrists don't usually bend past 90 degrees, so you should be good. It'd be really if you were just doing like really exaggerated stuff where you needed to break the rig in order for it to be more appealing or something. But yeah, so that's like my advice is just basically make sure your orientation of this joint is aiming at the child, so at the wrist, so your arm should be pointing at your wrist. This one should be halfway approximately down the center. It should also be a child of this, and the wrist should be a child of this. So they should both be independent, but this should not be a child of your roll joint. Then your rotation axis right here should be set up to something so that way your this axis here, in my case is the x-axis, whatever axis is running along the joint, that one should be the last thing evaluated, or the last number in the chain. So on this part, the x is last here, but it should, like, basically that all that means is that it's the first one to be evaluated, which means these two values won't override this one. And then the last thing to do is just basically set up the constraint, either an expression, this rotation divided by 2, or these two, and then the two parents, and then the child, and then or a constraint with just the x-axis.